impulse. If an unbalanced external torque is applied to a body rotating with an angular velocity omega 1 for a time t so that the angular velocity changes to omega 2, then angular acceleration. If an unbalanced external torque, if an unbalanced external torque tau is applied to a body if an unbalanced external torque tau is applied to a body rotating with an angular velocity rotating with an angular velocity omega 1 vector for a time t, okay, so that the angular velocity changes, so that the angular velocity changes to omega 2 vector, then angular acceleration alpha vector equal to change in angular velocity upon time, okay, equal to omega 2 vector minus omega 1 vector upon t. But torque tau equal to I alpha vector equal to this value, putting the value of alpha here, then I omega 2 vector minus I omega 1 vector upon time t or tau vector equal to I omega 2 minus tau t equal to I omega 2 vector minus I omega 1 vector, okay. The product of the torque and the time for which it acts is called angular impulse. It acts is called angular impulse. It's called angular impulse, okay. It is measured by the total change in angular momentum that the rotating body undergoes. If the torque acts for a small time dt, if the torque acts for a small time dt and brings about a small change and brings about a small change bring about a small change in angular velocity angular velocity angular velocity d omega, then angular impulse then angular impulse tau vector dt equal to id omega vector. Angular momentum and linear momentum. 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 Linear momentum is the product of cause and linear velocity. Angular momentum is the product of mass and linear velocity. Linear momentum is the product of mass and linear velocity, whereas angular momentum is the product of moment of inertia and angular velocity. Linear momentum vector p equal to m vector v and angular momentum vector j equal to I omega vector. Okay. Angular impulse and linear impulse. Angular impulse and linear impulse. Angular impulse and linear impulse. Okay. Linear momentum is the product of angular impulse is the product of torque and the time. Angular impulse is the product of torque and the time. It is also the total change in angular momentum. Linear impulse is the product of force and time. It is also total change in linear momentum. Okay, linear impulse vector f dt equal to md vector v and angular momentum equal to angular momentum tau dt equal to id omega vector. Okay. Angular impulse is the product of torque. Angular impulse is the product of torque and the time. It is also the total change in angular momentum. Linear impulse is the product of force and time. Linear impulse is the product of force and time. It is also the total change in linear momentum. Okay. Thank you.